in this example, we need to evaluate the double integral of y dA, where D is the triangle with vertices 0, 0, 1, 1, 4, 0. So again, the first step we need to do is we need to sketch the region D. So we have a region, and this region is D. We need to sketch this region. Now, sketching this region is very, very simple because he already is telling me that this is just a triangle with 3 vertices. The first one here at the origin. The second one is 4, 0, which is maybe this one 4, 0. 4, 0. And then we have 1, 1. Maybe 1, 1 is here like this. So this is the region. So this is my region. Now, we find the region. We need to decide whether this is type 1 or type 2. Do we have top, bottom, or we have left and right? Now, the first thing first is we need to try if this is as a type 1, which is top and bottom. So we put a triangle. Now, if we move this triangle to the left, it will start to be longer, but then what will happen to the top? It will start to change. So this is not a candidate for type 1. So what we will do, let's try type 2. Now, if we move this triangle to the top, the left and the right will stay the same. If we take this triangle down here, the right and left will be the same. So this is a very good candidate for type 2 region. Now, for type 2 region, this means y should be between 2 numbers and the x between 2 functions. 2 functions. That's what we have here. So we have to put a triangle and we find right and left. Now, let's start by finding, of course, we don't need to find intersection point here because all what we need to know is y is between what and what. Of course, y is between 0, because if we take this triangle down to the bottom, I will reach the 0. If I take this triangle to the top, the y will be 1. So those can be found easily. So it's a 0 to 1. Now, what is remaining for us is to find this function. Let me do it in green. This function here. And we need to find this function. I will do it in red. What is this function in terms of x? So I need to find it in terms of x. Now, how do we find the function? Of course, the function in green is a line segment, is part of a line. So all what we need to do is to find the equation for the line, even the one in red. So let me just go to the next page and find the equation of the line. Let me write it here as a note to find the green function, which is the one in the left. The one, sorry, in the right. We need to find the equation of the line. Which line? The line passing through 2 points, which is 1, 1 and 4, 0. Because the line in green is passing exactly through those 2 points. Now, what is the equation in the line in general? I just want to remind you, this is y minus y1 equal the slope x minus x1. And the slope, if we have 2 points, there is a formula for the slope, which is y2 minus y1, x2 minus x1, x minus x. Now, all what we need to do is we substitute x1, y1, x2, y2 in this formula. So this will be y minus y1 is 1 equal. This will be 0 minus 1, and this will be 1 minus 4. Sorry, it will be 4 minus 1. And here we have x minus x1, which is 1. Now this is y minus 1 equal. Now if we calculate this one, this will be negative 1 over 3 x minus 1. Now we need to do some simplification here and there. My suggestion is we multiply everything by negative 3, so I can get rid of this one here. So it would be negative 3y plus 3 equal x minus 1. The last step, or the final step, I know what is x. X will be negative 3y plus 4. Now you might wonder, why did I find x alone? Usually we keep y to be alone. This will go back to our region. I know this is type 2, and I know I'm trying to find x in terms of y. So this is why I keep x on one side, take everything to the other side, and now we find that this function is equal minus 3y plus 4, which is the function on the right. I will put it in the top of the integral. Now, we have to do everything we did for the line in pink, which passing through those 2 points. So what I will do, I'll just do it again here in this example in the same way. So to find the pink function, which is the one on the left, we need to find the equation, or we find an equation of a line passing through the 2 points. 0, 0, 1, 1. Again, the equation is y minus y1 equal mx minus x1. So we get y minus 0 equal m, which is y2 minus y1, x minus 0, which is y equal x. Now y equal x, that means if we want x alone, x equal to y, and that's what we get for the pink function. So far, we find the equation for the pink, we find the equation for the green. We know y between what and what, so the last step, we just need to evaluate the integral. How do we evaluate the integral? What was the integral in the first place? It was double integral of y dE. Evaluating this integral will involve 2 steps. The first one, I need to do the integral with respect to y, because y is between 2 numbers, and those 2 numbers are 0 and 1. If we go back to our sketch, this is our 0 and 1 for the y. And for the x is between the pink and the green. So it will be between y, and here will be negative 3y plus 4. Dx. Now, of course, this is easy integral. What's the integral of y with respect to x? Here I'm doing with respect to x, so the integral will be just constant, so it will be just y x, and then I do the evaluation. One time with, instead of x I write 1, and one time I write negative 3 plus 4. Now, this integral will be equal to integral from 0 to 1. It will be, if we substitute instead of y, the green one, so this is 3y plus 4, minus y, and then we substitute the function down, which is again y, dx. And this is a very easy integral from 0 to 1. This will be minus 3y squared plus 4y minus y squared dy. If we evaluate this integral, this will be negative y cubed plus 2y squared, negative y cubed over 3. We substitute it from 0 to 1. The answer will be here will be 1, negative 1 over 3. The answer will be 2 over 3. Thank you for watching.